And I'm back to making a backing plate for this ER32 collet chuck. And if you have been watching my previous video, you probably know why. If not, maybe that's for the best. It wasn't a great success story. Anyway, I got a great tip on how to make a screw-on backing plate. It really is very simple and logical, and I kind of feel stupid not to think about this myself. And I'm also surprised that so far only one person has mentioned this method in the comments after seeing my amateur machining screw-ups. So this means that there might be a need for a video about this on YouTube. So now you can basically watch the same video again with a little twist. To save a little time, I've already done the boring part and made a 40.75mm hole, just like the first time. I also made a nice 45-degree lead in for the 3.0mm pitch metric thread that I need to make. I believe I'm all set, so let's make a scratch. Dialing in a bit of a cut. Here we go. Stop. Beautiful. We're off to a good start. No need to check with the thread gauge, because the same gears are still on the lathe. The material I'm using is also the same. There's just a little paint on here. A bit of overspray from when I was painting something. I did remove the chrome coating over here to give the jaws some softer metal to grip onto. Alright, let's make another cut. Whoa. That was a long chip. For my second attempt at making a backing plate, I considered setting the compound slide 29 degrees to the other side, like this, and then cut the thread in the direction of the tailstock. But I'm used to doing it this way, and I don't want to confuse myself. Also, the thrust bearings probably won't work in that direction. Alright, I'll take a few more cuts now. Give myself some time to come up with something to say that will make me sound smart, intelligent and sexy. Nope, still got nothing. Doesn't matter, as the channel has 97% male viewers anyway. Let's do a spring cut this time. You may have noticed that I'm using a different threading insert this time. The box in which they came is labeled Mitsubishi, but I doubt that they are made by Mitsubishi. I paid about 10 euros for them on eBay, and the seller is from Hong Kong. Unlike those Banggood inserts I was using before, these have a bit of a raised edge on the pointy bit, and that should give them some positive rake. Anyway, a bit of positive rake isn't a bad thing on a small and low power lathe like mine. Let's do another spring cut. In the previous thread cutting video I told you guys that the maximum thread pitch for a 16 IR AG60 insert is a 3.0mm pitch, and that the flat spot next to the pointy bit would shave off the top of the thread to form the correct ISO shape. Well, this shaving off never happened, even though I cut the thread way too deep, and therefore the thread on the felt part is now probably sharper than an ISO standard thread should be. So I think these inserts will easily cut a 3.5mm pitch and maybe even a 4.0mm. These new inserts, by the way, don't have a flat spot, but they are rounded off, so if they ever get in contact with the top of the thread, they will form a nice rounded off top, and that probably looks better than a flat spot. Let's continue with the thread cutting. The last time I tried making a internal thread like this, I screwed up big time by cutting the thread way too deep, giving me a sloppy thread. I thought I could guesstimate the depth, but I was clearly wrong. So this time I set the compound dial here to 0, and so far I haven't made any cuts with the cross slide. This here is a drawing for an ISO thread that I got from Wikipedia. With the compound slide set to 29 degrees, the lathe cutter is basically running parallel with this side of the thread. I'm trying to make a 3.0mm pitch thread, so that means that this side of the thread profile is also 3mm. This flat here is basically the surface on the hole I bored in the workpiece, also called the minor diameter, D minor. So basically all I need to cut is this length here, and that's 3/4 of 3mm, and that's 2.25mm. So far I've done one full revolution on the compound slide, and that's 2mm, so there should be 1/4 of a millimeter left to go. I think I'll take out 0.2mm and then try test fitting the spindle. So let's take a few more cuts. I think it's time I started using a bit of loop. And now a spring cut. should be 2.2 millimeters. I'm pretty sure it still won't fit, but better safe than sorry, I guess. Whoa. It's starting to get tight, but that might also be a bit of swerve that's still left. I think this is pretty good. Yeah. I think this is pretty much perfect. I wasn't expecting that. I guess I got lucky. Here's a closer look at the threads I made. I think they look pretty decent. And I'm hoping they also look good on camera. But, well, most things don't look great in close-up. I must say that this Mitsubishi insert, fake Mitsubishi insert, cut a lot easier, lighter. It took less passes to get to this point. Too bad they're not sold by Banggood, because then I would try to sell you guys a shitload of these through my affiliated links. Alright, next I'll set up the boring bar, and then I'll cut the register. It's almost a shame that I need to cut out these beautiful threads. I changed to the boring bar, and now it's time to cut the register. Last time's mark is still visible. I believe it was 19.5 millimeter. So let's get this done. I think I better take a measurement now before I remove too much material and have to start over again. About 45.6. I'm using the same insert as in the previous video. You know, the one that made that squealing noise before I honed it a little. Earlier I was making macro pictures of the threading inserts, and I also had a look at this insert. This is a shot of the tooltip I'm currently using after it was honed during the previous video. It still cuts good and it also sounds fine, but I'm not completely happy with this finish I get. Perhaps I should speed up the lathe. Here's a shot of the other side of the insert. It also cuts still fine, but it leaves a terrible surface finish, even though that side was hardly used. If you look closely, you can see there's a very small piece missing. It almost looks like a bit of the coating got chipped away. And you can see the same thing on the shallow corner on the right, the one that's never used. I must say I'm not really impressed with these inserts. I believe they came with a 16mm boring bar that I bought from Banggood. They just don't last very long, and apparently they have manufacturing flaws. But with a few swipes of my trusty diamond hone here, I can extend the life a bit. I also tried to hone the damage side. It cuts good, but the surface finish is still shite. One day, when my channel rules the YouTube, I can probably afford buying nice and expensive branded inserts. Till then I will just suffer along using mediocre tools, like most of the amateurs in this world. Well, let's hone this insert once more and see if it will improve the surface finish. I'm only taking a very light cut because there's not much material left to do some surface finish testing. Well, I definitely didn't improve things. I'll hone it again, and for the next cut speed up the lathe to 900 RPM. The noise of the change gears, it annoys me. That's better. Still not great. But I think it should be good enough with some polishing. Besides, I need to polish this register to size anyway, because it has a small taper. Maybe I could have done a better job using a high-speed steel boring bar, but I only have very small flimsy ones, and I don't feel like setting those up. Let's take a measurement. And that's, whoa, 45.97, pretty close. That means that my 45.9 test gauge should already fit. And it does. Isn't that nice? It's pretty cold here at the moment, maybe 4 or 5 degrees Celsius. Perhaps the 46 test gauge will also fit. Nope, that's a no-go. I just measured my 46mm test gauge, and at the moment it's about 45.98mm. So it looks like I need to take one more very light cut, and then hopefully I can polish it to size. Well, I took my time on that one. Well, it will have to do. Here's the 46mm test gauge. Warmed it up a bit. Yep, it fits. Let's take a measurement with this snap thingy. Sorry. Well, that's just not right. $45.96 according to my calipers, and about 45.99 and maybe a bit according to the micrometer. I'm pretty sure that's still too small. I took another very light cut and it scraped out a bit more material. Yeah, that's okay. I think from here it's sandpaper. I wish I had one of those flapper discs that fit on the electric drill. It takes a long time to polish out 100th of a millimeter using sandpaper. So I got impatient and took another one of those very light cuts. But that didn't improve the surface finish. It now feels like there are high and low spots. Anyway, I will polish a little more and then I will test fit the spindle. Me and myself have been discussing if I should clean up the start of the thread, and I actually won that discussion, so we are just going to do it. I changed my setup. I decided that I will run the boring bar upside down, but this means that the compound slide has to be angled this way, and it's pretty close to the chuck, but the carriage is locked, so that shouldn't be a problem. A lot more stick out was needed to get out of the way of those jaws, but I think it will be okay. How does this look? Okay. That might be good enough. I think that looks pretty decent for an amateur like me. I guess now it's time to see if the spindle will fit. Here we go. Go. It fits. How boring. There's some play. To be honest, I would have liked things to be a little tighter. I guess I polished too much of the register. But, well, can't put it back, so I'll have to accept it. Well, that concludes the spindle thread / register cutting redo video. Next time I'm gonna try and see if I can mount that ER32 collet. I'm out of here. We're down to 4 degrees Celsius. It must be freezing outside. My nose is starting to drip and my feet are getting cold. So I'm glad I got this done. Till next time. So it's the next day and it's getting even colder in here. The wind is also picked up a little. But I'm feeling productive and I want to get something done this weekend. I'm starting a new project, making a simple cross drilling jig. And that's for drilling the bolt hole circle into the backing plate I'm making. So that's probably going to be my next video. I've been looking and thinking about this part I made, and to be honest, I'm not really happy with the end result. There's more play than I would have liked, and hopefully I can do better the next time, because I'm going to make another one for this little 80mm 4-jaw. And I also have a couple of vintage 7-inch chucks that I would like to put in use at some point. Anyway, that's a different story. I don't really understand how I managed to cut that thread too deep again. I just checked, and 2.2mm on the compound dial is in fact only 2.16mm. And the D minor, or the hole that I bored in here, was actually about 1/10 of a millimeter undersize. Sure, at a 29 degrees compound angle, the threading tool would cut slightly deeper than at 30 degrees, but I think that difference is almost negligible. The only thing I can think of is maybe my starting point was a bit off. I took some snap gauge readings, and I'm shocked with the results. Apparently I polished out way too much material. In the front here, the register is about 1/10 of a millimeter oversized. Near the back it's about 5/100th of a millimeter. I thought it was going to take ages to polish out 1/100th of a millimeter with 400 grit sandpaper. Clearly I was wrong about that, and I also shouldn't have taken that last cut. I don't think it will matter that much when it comes to concentricity, but I do believe that a tight fitting register will help prevent chatter. Maybe next time I'll get it right. But at least I learned a few things, like wearing warmer socks when machining in a cold barn. Alright, that's it. I'm going to put back the spindle on the old lathe. Since you're still here, how about watching a bit of advertising to support my channel? If everything went as planned, the good people from YouTube just showed you an ad for God knows what. Get used to it. The extra income might help justify me spending all that time in the workshop. I don't expect to earn a lot of money, but it should probably take care of the Scraptonium bill. And who knows, if this takes off, maybe in time I can buy a little milling machine. Not that I really need one, but think about all the video possibilities and fun I can have with that. Anyway, if you don't like ads, like me, I suggest you look into YouTube Premium, or just go watch another channel. I like David Richards. His old school content is great, and no ads. Well, I guess I'll have to start over again.